Right, definitely. So you mentioned about the LXNet, and initially before LXNet, neural networks were not really thought of much. They were, like you mentioned, introduced in past, but they were not used because people felt it won't really do the purpose, and it might not really make the machines intelligent, so as to say. Some people even doubt this is a real depiction of the neural networks that we have in our brain, which is still an
I mean, they absolutely are not the real depiction of the way neurons work in our brains. They are not. People are right.
right. There's people, some people who believe yes, there are people who believe no, there are people who say not at all. Personally speaking, personally, if I kind of have to provide my opinion, I don't know much yet, so I won't really comment as such. But I'm happy to know what is your basis to definitely, it won't be a real depiction of neural networks, which really makes sense. But still, let's say if you have to bring up a light on this specific topic, is it or is it not, or is it there? Is it there? It is up to some extent. It is in depiction, but after which it fails. And what is your opinion on this?
I mean, it
Because
is, you could say, the only, I would say, I mean, there are surface level similarities in there. First off, yes, the way human, or not even human, any neuron, like
mm-hmm,
neural nervous system of kingdom Animalia, from
mm-hmm,
starting from very tiny multicellular organisms, from like
mm-hmm,
starting from Hydra to up until blue whales and humans, it functions essentially on the same principle. You have certain chemical reactions going on. Your neuron pretty much is a cell like all other cells, and what it does is it fires activations. All right, what is an activation in and out of itself? So here's the thing: your neurons have capacity to interact with certain chemicals, certain inorganic chemicals. Actually, all of them happen to be salts actually, with
mm-hmm.
certain chemicals in very interesting ways. One of the interesting ways our neurons can interact, I'd say, with the inorganic salts is that depending upon the concentration of any particular kind of ion, be it positive ion or be it negative ion, upon detecting a certain threshold or concentration of these kind of ions out there, our neurons can actually start some kind of chemical response on the other end. Like neurons are generally elongated, so, and they have activators and sensor like mechanisms on both of the ends, not in middle. This is very important to understand. That's what makes neurons special out there.
Okay. Mm-hmm.
So let's say on one end you have dendrites, and those dendrites are sensitive to, let's say, certain concentration of sodium ions out there, Na
Mm-hmm.
plus. Although they work with potassium, like a whole bunch of S block elements our neurons make use of, and they actually work with a whole bunch of S block elements, positive and negative ions, both
Mm-hmm.
halides and S block elements. Anyway, so after receiving a certain concentration of a certain ion up until to a certain point of time, the neuron starts to to create something else on the other end of it. And when it receives something on the other end, then it starts to do that on the opposite end of this thing. So from here, the concept of weights and biases and activations comes along. So the neural activation or the neuron activation, this term originally comes from biology, actually, from
Right.
the neuron biology, from the cell biology. And we
Mm-hmm.
started to use the same term because you definitely can write some function out there which could, in a very approximately crude manner, mimic this functionality out
Right.
there.
Mm-hmm.
Now, so what are the similarities between artificial neural networks and our neurons, or let's say
Artificial.
biological?
Okay. Sorry. Yeah. Yeah.
What are the
Biology.
similarities? A, both of them have some kind of an activation function. We
Right.
don't know what is the exact activation function for biological neurons, but we do know there is some kind of function because it activates during certain temperature, during certain let's say ion concentrations. It activates after that ion concentration is sustained for a particular amount of time, and then the output is also pretty much fixed about these different inputs out there. So we know this thing, there is function. All right, let's code our simple function. We'll take an input, we'll do something with it, will give an output, and it will give a certain value or value up until a certain limit only when the input is something like this. Nice. Thumbs up.
Right.
You modeled it. The second similarity, which is between biological neurons and artificial neural network, ANN neurons out there, is that they have the ability to connect with each other. Now, if you want to write a computer system which is able to connect, yeah, just make one function call another function. And in reality, the way we actually implement neural networks, when you really open up the C++ code of TensorFlow or PyTorch, you'll come to realize it's a directed graph, basically. You're
Right.
traversing a graph, and then you are taking whatever the output was from the previous step, and you are feeding that as an input to whatever the output is on your next step out there. More or less, it's a directed graph.
Right.
Cool. And finally, we know that after showing things repeatedly and adjusting your activation function individually for every neuron, biological neurons can actually predict, detect, actuate, sense anything, abstract thought in case of humans, very abstract thoughts, and nominally abstract thoughts in case of other mammals. So
Okay.
we followed the same principle out there, and the similarities aren't there. One of a very important things, which is pretty much, you could say, straightforward for biological neurons to do, which is impossible with artificial neural networks, is neuroplasticity.
Okay.
Mouthful. It's a pretty big word out there. Now, here's the thing: what is neuroplasticity? When somebody meets a severe accident, particularly in the spine, there's a very good chance that unfortunately that person might end up paralyzed to a certain
Right.
degree. And
Mm-hmm.
then there is other kind of paralysis as well, when somebody, let's say somebody's hand is in a very bad accident, no damage to spine, but their neural nerves have been severed, then that person's hand has been paralyzed pretty much, done and
Right.
dusted for. What happens when in a severe injury somebody loses a portion of brain matter?
Mm-hmm.
Well, a lot can happen. A person can lose the ability to speech, a person can lose the ability of vision, a person can lose the ability of hearing. It is very unpredictable because different people's minds have work in a very different manner. However, here's a very important thing: brain has an intrinsic ability. It has been seen time and time again in patients where certain physical portion of brain actually was damaged or removed or lost. The person lost the ability of speaking, or the ability of, dexterity with their fingers, with his or her fingers. Over the period of certain time, when they were retrained into those things, they were able to gain these abilities one more time, aka some of the neurons in the head were able to pick up the tasks of the neurons which do not exist anymore.
Right.
And neurons are multi-purpose. And you might have heard about some people, particularly like overhyped hippie people. Actually, they were started shouting when LLMs came up. Yeah, AGI is there. It is sentient.
Right.
It knows it is sentient. So this actually came from there. These people started to argue that, okay, LLMs are the networks where they are doing general purpose things like, hey, look at them. We never trained them for writing poems, but they can write poems. We
Mm-hmm.
never trained them for doing analysis or summarization, but they are doing analysis summarization. Now this is hogwash. Let me be very honest about this thing. There
Mm-hmm.
are, yeah, we have problem of explainability in AI, but this shit has been explained pretty nicely.
Mm-hmm.
So, why? Okay, claim one: artificial neural networks work like neurons in brain. No. Why? Because we don't even know how neurons in brain work.
True.
So yeah, there is that. They mimic the behavior in a manner that you could have, pair of tongs, chimta. You could say the pair of tongs mimic the behavior of fingers. Yeah, in a sense it behaves, but does it function like fingers? No, it doesn't.
True.
It's that kind of analogy: fingers versus tongs. So
Mm-hmm.
ANNs, LLMs, diffusion models, they are tongs. Biological neurons are fingers.